Hydrogen is often called the fuel of the future, clean, powerful, and abundant. It could power our cars, store renewable energy, and run heavy industries, but producing green hydrogen has been too expensive. The culprit? A single rare metal, iridium. Now scientists say they may have found a cheaper, stronger alternative. This discovery could reshape the global energy landscape. Hydrogen is the universe's most abundant element. When used in fuel cells, it produces only water vapor. It's a critical tool for countries aiming to cut carbon emissions. To make green hydrogen, electricity from renewables splits water into hydrogen and oxygen. The tricky part isn't creating hydrogen, it's making that reaction efficient enough to compete with fossil fuels.
A catalyst lowers the energy needed to drive the reaction. Without it, splitting water would require far too much energy.
Catalysts are the key to making green hydrogen economical. For decades, the best catalyst for splitting water has been iridium oxide. Iridium is extremely rare, mostly a byproduct of platinum mining, and costs thousands per ounce. Global supply is tiny, not nearly enough to meet projected demand for a full hydrogen economy. That scarcity would make iridium an Achilles heel for scaling hydrogen. At current prices, iridium makes large-scale green hydrogen economically impractical. A cheaper, abundant catalyst is needed to remove the bottleneck. Enter a breakthrough that changes the search for catalysts. Northwestern researchers devised a way to test millions of materials at once. The Mega Library is a fingertip-sized chip holding millions of nanoparticles, each a different recipe. Rather than testing materials one by one, it screens hundreds of millions of combinations in hours. It's like unleashing an army of millions of tiny scientists, each testing a new material simultaneously. Massive data sets let researchers rapidly identify promising candidates. They tested combinations of 4 inexpensive metals: ruthenium, cobalt, manganese, and chromium. From roughly 156 million possibilities, one recipe stood out. The winning material? Ru-52, Co-33, Min-9Cr6 oxide. At the particle level, the elements worked together to speed the oxygen evolution reaction. In lab tests, it matched or outperformed iridium and crucially remained stable. Performance, higher activity than iridium. Cost, about 16 times cheaper. Stability, 1,000 plus hours in acidic tests. A cheaper, stable catalyst removes a major barrier to scaling green hydrogen.
This could be the turning point for hydrogen economics.
This could slash the cost of green hydrogen, making it competitive with fossil fuels. Hydrogen could replace coal and steel making. It could fuel long-haul trucks, and serve as backup for solar and wind. Beyond hydrogen, the Mega Library plus AI could speed discovery of better batteries, fusion reactor materials, medical implants with tailored properties, and optical materials for next-generation communications. By replacing a rare, costly metal with a smarter, cheaper alternative, scientists may have opened the door to a true hydrogen revolution. The world is watching. Can we scale this fast enough to power a carbon-free future?